Hello and welcome to the North Sea Decarbonisation Conference, organised by EIC and the international partners Agoria, Danish Exports Association, IRO and World Forum Offshore Wind. All slides and session recordings will be made available to attendees after the conference has ended. Before we start the session, we would like to go over some simple housekeeping items. We want this session to be as interactive as possible, so please feel free to direct any questions to our speakers through the live Q&A tab on the right-hand side of your screen. To expand your screen, hit the arrow button at the bottom right-hand side of the audience screen. To exit widescreen mode, hit the escape button on your keyboard. If you are having any technical issues, please click the link at the bottom left-hand side of your screen for useful tips. Alternatively, visit the Live Support Hub, which can be found at the top right of the web page, and a member of our team will be able to assist you. All conference supporters can be found in the Supporter Hub on the right-hand side of your main page. Our supporters will be available across both days, so please ensure you visit them in between sessions. Given that we would like this conference to be as interactive as possible, please have a look at our Meeting Hub. It is a perfect opportunity to connect and interact with other attendees, supporters and speakers. Once connected, you will be able to chat and video call at your own convenience. We hope that you enjoy the North Sea Decarbonisation Conference. If you have any additional questions, please contact the team at events.uk@the-eic.com.
Good afternoon, everybody, and welcome to this session on ocean energy. My name is Donna Cagney. I'm the Policy Director at Ocean Energy Europe. We are the trade association for the sector, and it's my pleasure to be moderating this session. A most appropriate session, I think it is, to have a session focused dedicated to ocean energy in the context of the decarbonisation of the North Sea. We're seeing both the UK and the EU targets emerging for ambitious deployment of ocean energy by 2030. So we are going to see a surge in the development of the sector, and there's a huge amount of industrial capacity that we're going to need to get our hands on. On the other side of the fence, the existing offshore sector has a lot of skills, competencies and expertise that will be really valuable for this expansion, and they're fully aware that they need to transition and to decarbonise. We're already starting to see this with big names like Saipem, Eni, Premier Oil, SBM Offshore and Total, to name but a few, dipping their toes or getting more involved into the ocean energy space. So I don't know whether it's going to be a match made in heaven or a shotgun marriage, but we're certainly going to see a lot of people going up the aisle between these two sectors over the coming years. We've got a great panel with us here today, a number of experts who have both experience and achievements that they'll be able to speak about. I'll introduce them all one by one individually. Just to remind yourself, as you listen to these speakers, if you've any questions, just pop them into the live Q&A box at the bottom of the screen. Okay, first up we have Elaine Buck from the European Marine Energy Centre in Orkney. So like Orkney, Elaine is involved in really wide range of different energy transition activities. She's really at the vanguard of the energy transition in her daily work. So really looking forward, Elaine, to what you have to present for us today.
Thank you very much. I appreciate being invited to the conference today, and thank you for thank you, Mocean, for the hosting also of this session. I'd like to go to our first slide. So I'm going to be talking more about the demonstration that is happening up here in Orkney, and also talk not just about ocean energy, but how we are integrating other forms of energy into marine and tidal. Next slide. So first, we just have to talk about the resource capability up here in Scotland and certainly around Orkney. On this slide, we're focusing a little bit on the tidal side, but in and around Orkney and in the UK, we have about 7.5 gigawatts of tidal potential, which is 25% of the EU capacity. We also have at our EMEC site specifically 4 megawatts, as well as at our Billia Crew site, we have at about 10 megawatts. In terms of the wave resource potential, we have 14 gigawatts of potential, and this is about 10% of the EU capacity. So as you can see, Scotland's renewable energy electricity generating capacity in total may be up to about 60 gigawatts or more, which is 10 times greater than the existing capacity from all of the Scottish fuel sources, which is about now probably a little bit more, but about 10.3 gigawatts. So most of the renewable energy remains untapped. Next slide. So this slide is really just to demonstrate the opportunity that we have developed through our years here as the tidal and wave test site up here in Orkney. So this has been developed over a number of years and certainly further south. So I think the value here is that in 2003, when EMEC was established, there was a very serious focus around how we could build up the supply chain and how a supply chain would be attracted to what was going on up here in Orkney. So certainly around the ports and harbors, we had two major infrastructure projects, which was upgrading and lengthening our quaysides so that we could allow more devices alongside and deployed up here. A number of marine contractors you all may very well be familiar with, such as Green Marine and Leask. They have cut their teeth on all the deployments that have happened up here in Orkney waters. And then I'd say that we're bringing manufacturing back through Ocean Energy to Scotland. So, and I'm sure that Chris is going to be talking a little bit more about this with the Orbital presentation, but it's the manufacturing that was happening down in Dundee with the O2 device. And what this has done is this has brought up a large number of skilled individuals. I do know that the economic impact assessment that was done back in 2019, it was a report that EMEC procured, is quite impressive. So between 2003 and 2019, the GVA to the UK economy is approximately 306 million pounds, and that equates to about 4,517 FTE job years. So we do expect this now to steadily increase with the offshore wind deployments and further hydrogen deployments that I will talk a little bit more about the hydrogen in some next slides. Next slide, please. So I'm just going to briefly give an update on what's happening at the EMEC site over this spring and summer. But our history, our pedigree is quite significant. We've had 32 different devices, wave and tidal devices, which equates to 20 different developers across 11 different countries that have been up here in Orkney waters. Next slide. So I don't want to take too much away from either Chris or Cameron's presentation, but I just wanted to talk a little bit about the trajectory of Orbital. So when they came up to Orkney and deployed, they had a 1/5 scale back in 2010, and then they developed the SR250, which was deployed at our site from 2011 to 2013. And quite significantly, they had over 4,000 hours of operation. So lots of learning with that 250 device. And then further in 2016 to 2018, the SR1 2000, or their 2 megawatt device, and in 1 week, they were able to generate 116 megawatt hours, which equated to 7% of the Orkney electricity demand. And now we're very pleased to host the O2 2 megawatt device, which is waiting to be installed on our site this spring. Next slide. Magallanes, who is a developer from Spain, has also had a successful trajectory in their deployments. So in 2014, they came up and they deployed a 1/10 scale device at the Fall of Warness. And then in 2018, they came back and they had towed all the way from Spain their ATIR device. And this was connected to the grid, and they are now currently in Scapa Flow, waiting to, actually, they've been in Scapa Flow, and over the last week or so, they are attempting connection to our electric cable at the Fall of Warness. Next slide. So what we hope to see is through the Wave Energy Scotland program, similar trajectory. So we are very pleased to see Mocean. They are on their way to EMEC, and I'll let Cameron talk more about that. Next slide. We also have another Wave Energy Scotland developer that is coming on site, AWS. So they will deploy a scaled wave swing wave energy converter on our site. Next slide. Now this is a bit of a difference. We actually have Technologies for Innovation, which is a company that is developing a mooring component. So it's an elastomer mooring component for floating offshore wind, and they're planning to do some tests at our site as well. So it's not just wave or tidal generating devices, but we also deploy components to shake out the reliability and improve reliability on these component devices as they're in sea. Next slide. Okay, so now what we're going to go to is we're going to talk a little bit more about how EMEC is demonstrating the integration of ocean energy into other systems. And I think the key to this slide here is what's been happening in Scotland. So on the far right side, Nova Energy up in Shetland deployed an integrated tidal turbine with a Tesla battery. So this was producing a base load for tidal power. And on the left-hand side, EMEC is preparing ground currently on our ED site for a 1.8 megawatt hour flow battery. This is the world's first to see Infinity Energy Systems delivering a 1.8 megawatt hour vanadium flow battery at the EMEC tidal site. So these batteries can store and discharge industrial levels of power over a multiple daily cycles with a lifespan of 25 years with very, very little degradation. This pilot project will aim to demonstrate the batteries, and they can bridge the natural variations that we have in tidal power with consistent energy requirements of hydrogen electrolysis. So really the benefit of integrating these batteries is they store the electrical charge in liquid form rather than a solid, and they can provide these industrial quantities of power for a sustained period of time, and they can deeply discharge without damaging the fuel cell itself. This will stand as a fully charged for extended periods without actually losing charge. So these are all necessary qualities to integrate battery technology with renewable power generation and hydrogen production processes. Next slide. So this, when we talk more a little bit about hydrogen production at the EMEC sites, our hydrogen really started with two key demonstration projects, one called Surf and Turf and the other one Big Hit. The objective of these projects was to enable Orkney to make use of the electricity that was generated locally. We also wanted to reduce the importation of fossil fuels and support Orkney companies to harness this locally sourced energy. So both these pictograms basically depict the project and the use of onshore wind and tidal generation that was integrated into our energy system. If you can see on the left-hand side, it's quite hard maybe to see, but we have tidal generation as well as an onshore wind turbine on the ED Isle, and this is connected into EMEC's substation, where the electricity is either exported to the national grid or it is used to power a 500 kilowatt electrolyzer that produces hydrogen. That hydrogen is then transported back to the mainland in Kirkwall, where it's put into a fuel cell, and this is used to actually make electricity and heat. And it's used not only for transportation, but it's also used for the vessels at the port side in Kirkwall. And on the right-hand side, it's just a little bit more of a detailed drawing, but I think the key aspect of this is the energy management system. So we're creating a model so you can actually see the use of tidal as well as onshore wind, or eventually offshore wind, and how this would look in a energy management system model for Orkney. Next slide. The next picture was, this was based on Microsoft coming to EMEC, where they were deploying a data center, subsea data center. This project was decommissioned last year, but it did prove the concept of underwater data centers. Microsoft understood the real challenges of onshore data centers, such as corrosion from oxygen and humidity and very, very high temperature fluctuations, keeping data centers cool. So they designed a sealed data center that could be put into the sea that would help provide more of a stable environment in the data center. So after decommissioning, they learned a lot about the biofouling that happened on the data center itself. If you can see in the lower right-hand side, I think they expected after 2 years that they would see a significant amount of biofouling, but there wasn't as much as they anticipated. And they also did a lot of testing around the gases internally and how that impacted the operating computers that were located in the data center. So there's going to be more and more significant opportunities with in-sea data centers. Next slide. So I'm going to be ending my presentation really just talking about the demonstrations that have happened up here in EMEC, the lessons learned through deployments or getting the metal wet, and the performance achieved through a lot of developer patience and the blood, sweat, and tears through technology development. Eventually will get us to sort of a repetitive and what we call boring trajectory, and thus standardization. So we should see more and more from single device deployments through to arrays in the coming years. And as we put more in the water, as we learn, we start to prove their performance, it will start to become more repetitive and standardized and become a significant contributor to the UK's renewable energy generation. So thank you very much for letting me present today, and I look forward to the questions.
Thanks very much, Elaine. Yeah, EMEC really having quite a few plays into emerging technologies, and really good to see that they're seeing how these technologies interact as well. It gives us a first sense as to what the energy system of the future is going to look like. If you have any burning questions for Elaine, don't be afraid to use the live Q&A button at the bottom to type them in. We'll take them on at the end. Okay, moving on to our next speaker. It's Simon Cheeseman from ORE Catapult, well known in the sector as driving the Tiger project, one of the most ambitious and far-reaching projects in the ocean energy sector to date. So Simon really is the sector's Tiger King. So Simon, what have you got for us today?
Good afternoon, everyone, and thanks for this opportunity to present. So I'm Simon Cheeseman from the Offshore Renewable Energy Catapult, and as was said, I want to talk to you predominantly about the Tiger project, which is the largest tidal project in Europe and one of Europe's largest funded projects. But first, I'd like to tell you a little bit about myself, a little bit about the Catapult, and then about the sector in general. So this is me. I've got a background in wave and tidal technology, probably about 11 years now. Previously with the Energy Technologies Institute as their wave and tidal program manager, running a lot of trials up in Orkney. So very familiar with the work of EMEC and what Elaine does up it's great to see so much activity going on up there, not just in the wave and tidal space as well. But I run the Catapult's office down in Hale, down in Cornwall. If we switch to the next slide, please. Thank you. So here you can see a map of the UK. The Catapult is a UK-wide national organisation. We're an independent, not-for-profit technology innovation organisation, and we're designed to work with academia and industry to help develop innovative technology that drives down the cost of energy. And you can see down in the bottom left there of your screen on the map is our office in Hale. But you come to any of the offices and you go through the doors, and we're the entry point into the overall Catapult organisation. We've got over 200 plus employees now that are that are working there with both SMEs and original equipment manufacturers to sort of develop innovative technology, and also doing policy work with the government. Next slide, please. So we've also got major test assets that we look after on behalf of the nation. And here's just a view of some of the things we've got. We test offshore wind turbine blades, we test powertrains. We've got a electrical laboratory where we test electronic components. We can test equipment before it goes offshore. We do pre-commissioning work. And more we're getting into sort of autonomous systems and sort of autonomous asset surveillance and testing equipment. Next slide, please. So the story for wave and tidal, really, in one slide. Back in 2017, we were commissioned by Renewable UK to have a look at how wave and tidal would fare against the UK government's clean growth strategy, and in particular 3 tests that were in there. The upshot of this was that really the UK government were not really paying close attention to wave and tidal technology. The focus was very much on offshore wind, and we wanted to try and readdress that by saying that there's something really good here from a UK perspective, from an indigenous manufacturing capability, from an injection of investment in coastal ports, and also an opportunity to sort of demonstrate how sort of wave and tidal could reduce costs. Gathering evidence from the sector, we produced a benchmark report back in 2018 that's available to freely download off our website. Contact me, I can send you a copy. And really what it said, and if you look at the chart on the left, at the moment, and this is focused on tidal stream, so apologies to Cameron, we didn't quite get the same sort of response on wave to enable us to sort of put together some sort of cost reduction forecasts. But for tidal, and the principles do apply to wave, we're about £300 per megawatt at the moment. What we needed to see was more deployment. Through more deployment, we get learning by doing. Through learning by doing, we start to reduce costs. With innovation, we start to reduce costs. That would grow investor confidence. And we forecast that by the time we got to about sort of 200 megawatts deployed, we'd start to see the costs come down to about £150 per megawatt. And as we push through greater investor confidence, we'd actually see a reduction in cost of capital, which is one of the problems for a lot of wave and tidal developers, is access to affordable cost of capital and affordable insurance. And what we forecast was that really by 1 gigawatt deployed globally, we'd see a position where certainly tidal was coming in at under £90 per megawatt, makes it competitive with UK nuclear. And because tidal is the only renewable energy source that's entirely predictable, there's a view that tidal at capacity could provide some sort of contribution to baseload. So we presented this to government. We got government's attention, but what they said was, what are the stepping stones to make this happen then? What really needs to happen? It was a bit of a chicken egg argument, because at the moment it was difficult for wave and tidal companies to bid into the contracts for different auction round, because it was dominated by offshore wind that could bid in at a much larger capacity. Anyway, we took this, and fortunately we were able to identify a funding call that was coming up. And if we turn to the next slide. Thank you very much. We developed what we now call the TIGER project, Tidal Stream Industry Energizer Project. This is, you can see the figures on there in terms of how large a project it is and the sort of duration out to June 23. But really what it's doing, it's a UK-French cross-border collaboration project. It's addressing the issues around not only cost reduction, but also sort of helping society understand the benefits that tidal energy can bring, and also looking at creating a UK-French supply chain. So if anyone in the audience out there is part of the supply chain is interested in this, sharpen your pens and pencils, because the next couple of slides will be the stuff that you really want to sort of copy down. It's funded through the Interreg Channel region, and it's led by my organisation, my team from the office that I run down in Cornwall. So let's have a look at a bit more about what Tidal actually, Tiger actually covers. Okay, next slide, please. Okay, these are the badges. If you're a badge collector, these are the people in the project, and a lot of those are on the call today. So Orbital, EMEC, and Minesto, with Ocean Energy Europe being a key stakeholder. Next slide, please. Okay, so really this slide shows you the geographical region in dark green, which is covered by the project. Unfortunately, on the south coast in the UK, we haven't got many active tidal sites, so we've stretched our boundaries up to Wales. But what you've got is a combination of developers there and sites that are pre-commercial, that are being switched on, and developers that are installing equipment through the Tiger project. Next slide, please. And some of the other work that we're involved in, it's not only about installation, it's also about providing sort of education material for beyond the sector, encouraging collaboration, encouraging technology innovation and development, growing a UK-French supply chain, and creating new sort of technology designs. Next slide, please. Okay, so this is a bit where if you're a supply chain company, you may want to take a closer interest in this. We've got a couple of events coming up, one on the 10th of June and one on the 15th of June, which are Meet the Buyer events. And this is an opportunity for the supply chain to get engaged with this project and actually help contribute in terms of technology innovation, support some of the deployments and development of some of the sites. So we've got funding within the project to be able to support supply chain engagement. There will be procurement calls. Procurement calls have already happened. They continue ongoing until sort of the end of 22. And there's an opportunity to work with the Catapult and do testing with the Catapult, sort of engineering finance available through the project to enable you to do that. Next slide, please. If you want to get involved, this is the Tiger homepage, and the big red says just press here to get your updates on those events and many, many more that ourselves and the partners are actually promoting through the project. Next slide, please. Okay, that's all from me. So the message is that Tiger is a live, active project. You can get involved if you're part of the supply chain. Really want to hear about your ideas for new innovative technology, how you can work with the project partners, how you can support the sites. So I really encourage you to register on the site and help us drive down the cost of energy for tidal stream. Thank you very much.
Thanks very much for that, Simon. Great project, the Tiger project, plenty going on, plenty of opportunities to get involved as well, as Simon said very clearly. So let's hope that some people in the audience will get in touch and get involved in the remaining activities. Moving on to Chris Mill from Orbital Marine Power. Now, I'm sure most of you may have been familiar with Orbital Marine Power. If you weren't before, you probably were over the last couple of weeks. There's been a huge amount of media coverage. So I'll put the mic across to Mike to give us to Chris to give us an update on what's going on there.
Donna, hi, thank you very much. And thank you also to EIC and everybody else involved in setting up this conference. No mean feat and in the current climate. So thank you to everyone. My name is Chris Mill. I'm the CFO of Orbital. As Donna said, hopefully this is a name that if you're not familiar with so far, you will hopefully become familiar with in the weeks, months and years ahead. If we can move on to the next slide, please. So for those that are less familiar with the sector, one of the things that is probably important to point out here, the tidal sector, like oil and gas before it, is sorry, sorry, my apologies. The tidal sector, like oil and gas before it, is developing due to the need to solve a problem. That problem is that we need to tackle the global climate crisis, and we need to meet the world's growing demand for electricity and power. Now, countries around the world are legislating to try and meet net zero carbon emissions, and utilities and power providers, they need diversified portfolios. They can't just rely on renewable energy sources such as wind and solar because of the correlation there. We need to have negatively correlated power generation sources which give us a more robust system. So, tidal energy is very much part of the solution. It's not the only solution. We're not sitting here pretending that we're going to solve all of these problems. But the marine sector, and tidal in particular, is one of the early steps that we can take to solve the problems that the global climate crisis is presenting. And of course, it was noted from Elaine in her previous session, some of that will come with utilising this source and combining it with things such as green hydrogen and battery storage to help produce even more predictable baseload, low carbon energy. Next slide, please. So what's different about Orbital? So we've got a unique floating platform. It's very different to some of the technologies that have been proposed in the past from the tidal sector. One of the key things that MD who's involved in any kind of maritime heritage or operations is aware, the sea can be a fairly unforgiving and hostile place. So whatever solution we come up with, it needs to be robust. Now, one of the things about our floating design and our IP protected retractable leg system is that it can be towed, installed and serviced at the sea surface using just small towboats. So we use what are called multicats for all of our installation and construction activities. Now, obviously, the device itself is constructed on shore in a nice, dry, controlled environment, and then it's towed out to site and installed on its moorings. Now, these low-cost workboats, they can cost us something like £3,500 a day. Compare that to the heavy lift vessels that may be required to put some heavy equipment down on the ocean bed. And you can see there some of the cost advantages that this approach has. Now, obviously, the key thing about this cost advantage is what we're trying to do here is find a technology solution that can become cost comparative and indeed cost competitive with more traditional or more advanced, maturer technologies, such as wind and solar. So a real key difference here is, and part of the reason that we believe that we've got a step change in the levelized cost of energy, and that's something that we're trying to evidence further with Simon and his team in the Tiger project. Now, one of the key things, just to help people again just visualize and sort of conceptualize what our technology does here, I very much look at this as almost like a boat in reverse. So if you think about it, normally a boat would have its turbines, the rotors turn, and it propels the boat or the vessel through the sea. What we are doing here is holding the turbine geostationary and effectively letting the tide push the blades, turn the turbines, and effectively it's a boat in reverse. The energy sort of flows the other way, and effectively instead of using that energy to propel the vessel through the sea, that energy is essentially converted into electrical energy and transferred back to shore. So actually it's quite simple. And if you think about it in that way, a lot of the technical challenges that face the industry have already been solved. Shipbuilding, some of the issues around oil and gas, the use of umbilicals, some of our systems have turrets. All of these engineering challenges have been solved before. They've just never been applied in the right way in the tidal or marine energy setting. And hopefully that's what we're doing. And, with good success so far. If we can move on to the next slide, please. So this is a short video. Hopefully it will start playing. Yep. So this is a short video just of the recent launch of our most recent O2 2 megawatt tidal turbine. So this spacecraft looking turbine is approximately the size of a Boeing 747. So, pretty big. But with that size comes a large amount of generation. This is a 2 megawatt unit, and it can generate enough clean, predictable electricity for around 2,000 UK homes. It can also offset 2,200 tonnes of CO2 production per year. Now, with a practical resource in and around the UK coastal regions of around 15 gigawatts, this breakthrough technology can make a significant and near-term contribution to the UK's aspirations towards net zero. Very important. Now, globally, the tidal stream market represents long-term sales and servicing market of potentially 100 gigawatts. That's 100,000 megawatts for those unfamiliar. Now, that suggests a future market for sales and servicing of around 20 billion. Now, we are not, again, we need to be honest here. The resource is not such that we are going to be as big as wind. The resource just isn't there. But I challenge anybody to tell me that a £20 billion annual market is not big enough, a big enough prize indeed, for the UK to try and win and own a good proportion of that moving forward. Now, of course, that's what we're seeking from government at this point in time. We are looking for the government to put in place early market support mechanisms, just as they have for solar and for wind in the early stages, and effectively allow us to try and entrench a supply chain here so that we can own that global market opportunity moving forward, or at least a good proportion of it. Now, what I'm going to do here is for those in the audience from the supply chain, looking at this as a potentially the next big offshore global market that could be a market for them to sell their products into. I'm going to now sort of just give a little bit of a breakdown as to how we see the potential and what areas we see that potential to be largest in. So the subsystem breakdown that's shown on the screen now, which hopefully you can see, just shows some of the main components of our turbine. You've got the blades, which obviously get turned by the tide. They're attached to the sort of the power takeoff system and equipment, which are housed in the nacelle. We do have a pitch system, which means that our blades can take the tide from either direction and extract the energy. We don't need to turn the turbine round, which we have in some of our earlier iterations, and which might actually still be a good solution moving forward in some sites. We've also got the legs, the structure of the hull. Inside the hull, we've got all the electrical systems, and various other sort of transformers and electrical components. If I can move on to the next slide, please. Now, this is our second 2 megawatt unit. Now, we're very proud to say that the UK content on this second unit is very high. It's 70-75%. And there's just a little selection of the areas where we've procured some of the equipment and services. Now, what you'll hopefully see there is that the UK knows how to do this. We've got the skills, we've got the facilities to effectively build out these early projects and entrench that supply chain and that expertise and help drive that cost reduction. So the industrial opportunity is very much akin to shipbuilding and uses the manufacturing supply chain are actually sort of in the industrial heartlands of the UK and actually around former shipbuilding areas. So, operationally, the projects then move into being located in coastal areas, such as Orkney, and the projects then bring significant long-term benefits because these are projects that will have through the operational phase of the life, which could be 20 years. This isn't somebody comes in from overseas every 5 years to do maintenance and disappears again. This is on-site, regular access project teams. So hopefully you'll recognize some of the names on that list. And hopefully they might be either yourself or some of your competitors. So this is a real live opportunity for the UK supply chain. And please do take note. Move on to the next slide, please. So just thinking about how this moves, so this sort of color coded around the previous breakdown of components. There's certain areas right now that are difficult for the UK to own. So the blue sections there around the pitch and hub and nacelle. There's entire towns built around sort of gearbox manufacturing facilities in Germany. But that doesn't mean that we can't start doing assembly and work like that here in the UK, just as the Danes have done with the wind industry. There's a huge amount of assembly that gets done in Scandinavia, and then they export it to us here in the UK. There's no reason why we can't reverse that on a global scale for the tidal sector. There's no reason why we can't embed some of the manufacturing capabilities here in the UK and use that, yes, for domestic projects, but actually entrench again some of that for the global scale projects and the global opportunity that will come beyond this. You know, the breakdown here is looking at an £80 million sort of project, just looking at sort of roughly how that could be split. For the supply chain members in the audience here, do look at that. Hopefully it's big enough for you to see. Look and see which area your company fits in. See what the opportunity could be for you. And of course, you know, do your bit to help support us making this an industry of the future. Next slide, please. So I'm just going to leave you with a message again, just about the broader tidal space. You know, every day, vast but untapped tidal energy flows through the sea channels and passes our coastlines like clockwork. Orbital's turbines can capture this power. We can produce a reliable supply of electricity night and day, 365 days a year, whatever the weather. We're not the only solution that's going to solve all of the problems of the climate crisis, but we are one of them. So use your positions, use both internally within your own organizations and in terms of external facing lobbying with government. This is an industry that can happen. It's an industry that will happen, but let's make sure it happens here. Let's make sure that all the work that's went in to get the tidal industry up to where it is in the UK up to this point doesn't go to waste. Let's entrench the supply chain. Let's create an export market, and let's produce low carbon, low cost tidal power. I'll leave you with a couple of shots of the O2 as it. Next slide, please. Believe it, there's no photo CGI in there. That's the actual O2 getting towed up to Orkney. And next final slide, please. Again, no CGI in there. That's an actual photo of our turbine on its way up to Orkney a couple of weeks ago. So let's make sure there's a lot more of them to come. Thank you very much, and I look forward to the Q&A.
Thanks very much, Chris. And that's why you threw in those pictures of the O2 at the end, because I think that's probably what half of us were here for. Okay, moving on to our next speaker. It's Ocean Roberts from Minesto. Minesto, there's been some really positive and exciting news coming out from the Faroe Island project as well. So really looking forward to hearing an update from Ocean as to what's happening with Minesto. Over to you.
Thank you very much, Donna. Yes, again, thank you for the opportunity to present here. My name is Ocean Roberts. I'm a business development manager for Minesto. So if we could just skip to the next slide, please. Thank you. So yes, I'll talk to you a little bit about who we are as Minesto, what we've been doing, the sort of key achievements, and where we kind of want to go in the future, and to sort of reiterate some of the points already brought up in the previous presentations. And just before we start, this is an interesting picture here of our technology sort of about to be deployed in the waters off the Faroe Islands, like Donna mentioned earlier. So it is our deep green kite technology that's going to be installed there, and that's a really fantastic picture of it in action. I think you'll agree. So if we can just move to the next slide, please. Okay, perfect. So a little bit of history from Minesto, for those of you who don't know. Established or founded in 2007 from the start, Saab Group, and there are around about sort of 60 employees on the different Minesto sites we have around our sort of global footprint as a company. We've had a significant investment towards developing the deep green technology to date. We are a listed company. And we have successfully managed to export electricity to the grid using a commercial scale unit in 2020, which is a fantastic achievement for ourselves and for the industry as a whole. Our main owners, BGA Invest and Midrock New Technology, it says at the bottom there. So in investment highlights, I should call it, we are the only sort of verified technology that can produce power using low flow tidal or ocean currents in this industry. And we have that sort of unique global position to be able to tap into sort of a wider resource than there exists for conventional technology, as I would call it. Again, we're predictable. We're predictable many years into the future source of renewable energy, and can produce that at base load going forward. And we have a significant expansion potential for the technology throughout the world. Next slide, please. Okay, so just a quick graphic on what the sort of system looks like. It says from stream to grid. So if you imagine flying a kite in the wind, or a stunt kite in the wind, for those of you who don't know, you can act as the anchor. You can move that and manipulate that to fly a sort of figure of 8 trajectory in that wind. We effectively do the same thing, but subsea, using hydrodynamics rather than aerodynamics. So you can see different parts of the system there, where it's grounded at the foundation, at the seabed, exporting the power through an umbilical to a shoreside connection point. I'll leave it there, so we'll go to the next slide, please. And the exciting thing about this is we have sort of 2 product lines to provide us with this flexibility of where we can target. So we have the deep green utility device, which is generally available for sort of multi-megawatt arrays, or grid-connected farms, as we could call them. And we have the sort of deep green microgrid device, which can be used in sort of off-grid situations, whether that's sort of luxury tourism, or that's around peripheral communities in islands. And you can see, moving to the bottom there, the potential power for each device, the difference in size for each device, and the relative weight for each device, and the depths of installation there. And moving forward, just to talk a little bit about the technical proof of concept that's been going on over the last few years in Minesto, moving from that sort of 2011 date for model scale sea trials to commercial scale trials in 2018, and grid connected export of power in 2020. Move forward, please. Next slide. And the interesting thing there, people have been talking about levelized cost of energy in the previous presentations. So we believe that we can bring that down quite significantly. And the two lines you see there on the graph, a tidal stream versus ocean current, or comparing to ocean current. And you can see there that we believe that we can buy a sort of 1 gigawatt installed capacity. We can, for tidal stream, bring that down to around about sort of 60 euros per megawatt hour, and that is extremely competitive, I should say. And the cost drivers that enable that are our ability to produce these turbines with a significant yield at a really low relative weight. So the weight of the system is fantastically adaptable and low. That then leads us to be able to have a quicker and a more effective installation and operating procedure at these low flow sites, and it being low in weight, it brings down the costs. We can use smaller vessels, we can access the sites in larger windows, and we have a recoverable modular operations concept there. Next slide, please. Yes, excellent. So I'm not going to stick too long on this. We've talked in the past, that the other speakers have spoken, the need for the balanced renewable energy mix. So I won't touch on that for too long. But what we would want to say there is we want to see sort of renewables making up a greater part of the sort of total share in final electricity consumption that the world can see. So we'll skip that one, please. Fantastic. So this is an interesting slide from our perspective. You can see the global opportunity that already exists for our technology, for our deep green technology. We'll go to the Faroe Islands first. Extremely interesting. The government in the Faroe Islands there wants to become completely renewable by 2030. We have a fantastic relationship there with the utility at the Faroes, SEV or SEV, where we've installed 200 kilowatt devices in the last few months, and there's a scale of potential there to move that phased deployment towards a 70 megawatt install capacity at the Faroe Islands for commercial farms. And the UK, where I'm located, we have a project at Anglesey, Holyhead Deep, and that was our first utility scale demonstration project, successfully tested in 2018, and that again has this scale up potential towards 80 megawatts of commercial farm. France, Simons has spoken at length about the Tiger project, and that's again is a significant project from our perspective. That partnership with one of the sub-partners within Tiger, EDF, to install and operate a turbine of 100 kilowatt capacity in Pampol Brehat. Florida and Taiwan, these are potential sites for us when we're looking to move into capitalizing on the opportunities there for ocean currents. So there's a significant collaboration in those two areas from Minesto's perspective as well. Move to the next slide, please. It's just a little bit more detail on the Faroe Islands and Holyhead Deep. And the thing to say here is, yes, we've done these things here. We're looking for phase development to that maximum capacity, but here we are able to access that local supply chain using local suppliers for boats, for components, and it's very true that we're actively engaged in trying to work as closely as we can with that supply chain for the quality we need for our technology and for our subsystems. We'll move on, please, if we can. Now, this slide, we've moved forward in recent years, and just to show how competitive and how attractive our technology is starting to become within the market, is we're able to have those expanded and deeper sort of commercial partnership with significant strategic partners, such as Schneider Electric. That partnership was formed in 2021, helping us to accelerate our way to commercialization of the turbine. And again, I mentioned the collaboration with EDF in 2020. So last slide, please. So what we want to do here, what's our focus ahead for success? We absolutely need to, we have that baseline or that sort of robust platform that we need to deliver of projects in the pipeline, that we need to deliver on what's existing right now in our pipeline, which sets up a base for us to scale up towards, competitive 1.2 megawatts utility scale projects to enhance our sort of competitiveness in the marketplace. And that in turn then will allow us to expand into those markets I mentioned earlier, and to bring this industry to the fore when it comes to the global energy mix. And that is it for me. Thank you.
Thanks very much, Ocean. And I think some very tantalizing information there about the market and where the future deployments will be, as well as the exciting stuff that's coming out from the current deployment. So looking forward to digging into that a little bit more in the question and answer session. Just a reminder to the audience as well, if that's triggered any questions or any thoughts or any questions, please do use the live Q&A box. I see one person started to use it. We just need a few more questions, because we're coming up to our last speaker, which is Cameron McNatt from Mocean. With Mocean are also the co-hosts of the session as well. And Mocean is a very interesting company to watch as well, because they are one of the winners of the very stiff competition that was the Wave Energy Scotland programme over the last number of years. And I believe there's a deployment going up to EMEC as we speak, so we're all very excited to see how that turns out. Cameron, across to you.
Great, thank you very much. We're really so I'm Cameron McNatt. I'm the founder and managing director of Mocean. Really pleased to be speaking to you today, representing Wave Energy. You know, we're going to talk a little bit about, and as well as hosting the session today, we'll talk about, you know, how we see Wave Energy and Mocean getting to market, where we see the markets are, how we see the technology developing, as well as our experience through the Wave Energy Scotland program. And in fact, we are quite literally heading up to EMEC today. So our prototype was just loaded up onto a lorry, and it's actually catching the ferry from Aberdeen tomorrow on its way up to Orkney. So that's all very exciting. So it got some really cool pictures this morning, unfortunately not in this presentation. But anyway, moving on. Next slide, please. So Mocean was founded by myself and Chris Retzler. So my background is in naval architecture and software development. Chris was one of the co-founders and the principal scientist at Polamis Wave Power, which was once one of the biggest wave energy companies in the world. Now we've grown to a team of 16 people. Our headquarters are in Edinburgh, but we also have an office in Aberdeen. We've been very successful with funding to support research and development and commercialization, you know, albeit a big chunk of that coming through the Wave Energy Scotland program. We've just finished the 40-ton prototype that's been developed in the WES program, which you can see behind the team in this picture, and I've got more to say on that in a minute. Next slide, please. So Mocean's sort of key to our design of wave energy converters is a lot of experience. So we have, between myself and Chris and now our growing team, we've got a lot of built-in experience. We've worked with a really experienced supply chain, but one of the real benefits has been using software. So besides using commercial software packages, we've developed some of our own software that programmatically generates hull geometries, hull forms, shapes, runs them through a simulation. We then wrap that simulation up inside an optimization routine that searches for the best candidates, and we then build small-scale models of those and test them in wave tanks. All of this has resulted in a high power-to-mass ratio amongst other metrics. But you know, we've heard through with some of the other speakers, Ocean, and you know, the importance of increasing the power and lowering the mass or the size, where mass and size relate to cost, basically. So in the top right corner of the screen, you can see a sort of motion geometry compared to a standard hinged raft. And on the x-axis is wavelength, on the y-axis is power per mass. And what you can see is just by changing the geometry, we're vastly improving the performance compared to a standard hinged raft. Next slide, please. The Wave Energy Scotland program is a staged program. So you start the program at stage 0, which is essentially the application. So obviously, sort of prior to even entering, we had to have our concept for what we wanted to develop. And even back then in 2015, Chris and I were thinking about geometry, and we were using software. So back then it was pretty crude. We were just using kind of trapezoidal shapes, but we were able to demonstrate the benefits of using software and focusing on geometry in terms of improving performance. In stage 1, I would kind of characterize that as a 1-year feasibility study. We looked in more detail at concepts, considered the engineering, we improved our modeling capabilities, looked at LCOE, etc. But I think importantly, we started to identify problems. We started to identify challenges within the numerical modeling and things that we didn't understand. Fortunately, we were able to make it through to the stage 2 program, which I would call, it was an 18-month feed study. We further refined the concept, addressed the problems that we identified from the engineering and from the numerical modeling, and prepared ourselves for the stage 3 project. So stage 3 is really about building what you've developed in the previous stages into a real thing and testing it at sea. So we've been working on the stage 3 project for 2 years, and we have a prototype that is, as I say, just headed up to Orkney for testing. Next slide, please. So there it is in all its glory. Our prototype is called Blue X. So it is a hinged raft wave energy converter with an innovative hull geometry. Here you can see it sitting on its stand at the quayside in Rosyth. It's about 40 tons, 20 meters long. In the top right corner, you see it during the wet commissioning. So it floats nicely, nice and level and trim. And then, as I say, we are taking it up to Orkney for testing at EMEC. Initially, it'll be deployed at the Scapa Flow sort of test site for kind of shakedown testing, and then we will move to the EMEC Bilia Crew site to really put it through its paces. Next slide. But commercially, we are focused on developing a small-scale wave energy converter that we call Blue Star for offshore energy and small-scale power applications, such as powering oil and gas tiebacks. So Blue Star generates power from both waves as well as having solar panels on deck, and we're talking about power on the order of 10 kilowatts. What's really important to users is they need a continuous supply of power, and we address that through energy storage. So there's both batteries on board the system, and you can deploy more batteries subsea so that we can ensure a continuous supply of power. And it's not just power, it's communications. So actually having a wireless communications link to subsea equipment is very beneficial. And the machine itself is survivable and reliable. This is, been the result of all the work we've put in through the Wave Energy Scotland program, and it's small and easy to install. So we're focused on making it road transportable and easy to handle with vessels. It can be towed to site, it can be installed with anchor handlers or multicats, so relatively low cost vessels. Next slide, please. More than that, we are actually going to take our Blue X wave energy converter that's been built through the Wave Energy Scotland program and use that to demonstrate power for subsea equipment. So we have a project called Renewables for Subsea Power with some great partner companies, including ECOG, Harbour Energy, Modus, and Baker Hughes, funded by OGTC, in which we are going to connect our WES prototype to an umbilical, which will run down to a subsea skid, which will have batteries as well as subsea control modules and be connected to a residential autonomous underwater vehicle. So Mocean is providing the wave energy converter, ECOG is developing the subsea battery systems, Modus is providing a residential autonomous underwater vehicle, and Baker Hughes is providing the subsea control system. We are currently in phase 2 where we're building all of this kit, and we will commission it on shore, and that will lead into a field trial up in Orkney next year. Next slide, please. But overall, I would characterize our strategy as start small, go big. So I've already talked about the applications for Blue Star, and the value proposition is really just that we're providing power in remote locations where it's really difficult to get power and very expensive. Some of these are often called niche markets, but really they're pretty big markets. The subsea power market is in the billions for sure. But what our design process and the learning by developing Blue Star and applying it commercially will hopefully provide some cost reductions and revenue generation towards the development of our larger scale Blue Horizon technology. So we see the next size up that we will develop is a 250 kilowatt machine, which will have, again, applications in kind of niche markets, let's say. But this includes power for small platforms, power for remote and island communities, and power for things like offshore aquaculture. And again, that will enable the further development of a sort of larger megawatt scale machine. Next slide, please. We've heard a lot about the benefits of marine energy in terms of providing a balanced supply. I think it's pretty clear that we've got to have a very competitive cost of energy, but I don't think that we really have to undercut everybody else. I think the importance of marine energy, I think we really need to think about it as more complementary. So I'm showing a graphic here from a fellow wave energy developer, AW Energy, where they've really identified a sort of interesting case study in California. And in the top plot, you can see that the yellow and blue are solar and wind power production, and the green line is wave energy production, over the course of a year. And you can see that these things are really out of phase. So the benefit here is that we're providing a more balanced supply to the grid. while not quite as predictable as tidal, I think you can predict the sort of tidal flows years in advance. Wave energy is more predictable than wind or solar. So the waves that are providing energy at your coastline, the big swell, was generated by storms that happened out in the middle of the ocean, and you can actually predict the arrival of those waves, in some cases a week in advance, and certainly days in advance, which again is very beneficial to grid operators. And coming back to the idea that we're not competing with everybody is talking about combined wind wave farms. So ultimately, we see the deployment of the first utility scale wave energy being amongst wind farms, floating wind farms likely, where these turbines are going to be spaced a kilometer or two apart, and there's plenty of ocean space out there to install wave energy converters, which helps to reduce the overall cost of the development and again provide a balanced supply of renewable energy. Next slide. And of course, we've got to have an LCOE curve. I think we've seen a lot of these cost reduction curves. I just to kind of go through the bullet points, number one, there's a massive global wave energy resource. There's a number of non-grid applications and opportunities for wave energy to provide value while not competing simply on the cost of energy that allows us to develop the technology and learn by doing. Nevertheless, there is a really large market for grid scale ocean energy and really ambitious targets that are being set by the EU, the US, and globally. And so our position on the LCOE curve, so in blue, we see a kind of industrial spread projected by, I think it was from the set plan, and Mocean Energy is sitting at, for our first of a kind device, so if we were given a budget to build a machine right now, we would end up with an LCOE somewhere around 318 pounds per megawatt hour. And with our development plan commercially and our innovation program, we expect to have some really ambitious learning rates such that by a gigawatt of industry deployment of wave energy, we should be sitting around 117 pounds per megawatt hour. So we think that we really are well positioned to help take the industry forward. Next slide. Thank you very much.
Thanks very much, Cameron. And yeah, interesting to see that device go up into EMEC. And if anyone's in Aberdeen, be sure to pop down tomorrow morning to see it getting shipped off. And hopefully we'll see some great photos coming from that in the coming days and weeks. Okay, we still have a reasonable amount of time for some questions and answers to our panelists. We're bringing back onto the screen. And if you do have any questions in the audience, look at that live Q&A box in the bottom of the screen. You can type in your question and we'll pose them directly to the panelists. Okay, we've got a few coming in. We've got one question to the three developers on the panel asking about where these individual devices go, and she's citing the example of well, offshore wind, where obviously large farms. So I think we all know that these devices will be in arrays, so multiple devices together in the same site will be the next step. But maybe the question I'd like to ask to each of you is longer term, like 2050, 2060, once this sector is really scaled up, you're churning out a gigawatt of capacity a year. What's the biggest, most impressive kind of farm you would see in terms of a single deployment? Maybe we'll start with Ocean for that question. Oh, sorry, was that for me or Ocean?
No, I think it was for me.
Yeah.
Was it?
Okay.
It was,
yes,
yeah, not Mocean, Ocean, yeah.
I mean, it's a hard one to give you a set answer on it, Don. But like you say, you know, we're talking utility scale devices. You know, multi megawatts. We're already saying now at sort of 80 megawatts plus in Wales, and if we're looking at the UK, we're gigawatts of capacity around. So, you know, as long as we target the resource correctly and we are able to position the turbines where they work as efficiently as possible to draw as much out of the resources we can in the right way, you know, there are almost no limits to it, I'd say.
Maybe I'll jump to the other developers in a second, but just a follow-on question. I saw in your presentation reference to the work that's happening in Florida with the Gulf Stream, and it's the first one of the first times I've heard a commercial company starting about trying to exploit those kind of resources which are 24/7. Can you talk a little bit more about what the game plan is for those currents rather than tidal streams?
Yeah, you're exactly right. Those currents sort of take away any potential lag time that we see in the ebb, or between the ebb and flow of the tide. So if we're considering the sort of tidal flow as being near baseload, we talk about the ocean current as becoming a baseload resource. So right now we are at the sort of not really early stage, but at some sort of early stage of discussing and finding the viable sites for those initial ocean current installations, both with our employee in Taiwan and also with Florida Atlantic University in Florida, using the Gulf Stream there. So that's what we're looking to develop, and that really is where we can exploit the sort of greatest resource potential for this technology.
Thanks, Ocean. Yeah, maybe the same question from the audience to Cameron from Mocean. Where do you see kind of a longer term, large scale deployment of your technology? I saw in your slides the utility scale. You were careful to write that it would be co-located with wind. I mean, would you see arrays of your technology just one deployment, one technology?
I mean, I think anything's possible. But it makes so much sense to co-locate them with wind farms where you already have the offshore infrastructure, the cable, the project developed. When you start to look at these really large wind turbines that are being developed, the sort of 15 megawatt halide X, we're talking about rotor diameters that are 250 meters, and the sort of rule of thumb for spacing these wind turbines is 8 times the rotor diameter. So we're talking 2 kilometers between individual devices. That is a lot of room to fit wave energy converters. So, I mean, not to say that there couldn't potentially be, standalone wave energy deployments, but it just makes a lot of sense to deploy with wave energy. And so I don't know, this is a pretty kind of ghetto way of sharing this, but that's not going to work very well. This is our machine being transported by a truck. Just received this picture. So lots of very exciting things going on right now.
You've seen it here first. Thanks, Cameron. All right, and moving on to Chris as well, from Orbital, your longer term vision, like how big could an array of orbital devices be, and what would that array look like? How would it work?
Sure. Well, I mean, I think one key thing to draw attention to here is, there was reference there made to the rotor diameter and the swept area of wind. And of course, wind, literally the sky's the limit. But with tidal and with marine energy, actually the seabed's the limit. So, we've done a lot of work, again, with Simon and his team in Tiger, looking at reducing levelized cost of energy. And a lot of the levelized cost of energy reduction will come from scaling up. So the first answer to the question is, how big do we think a turbine will go? Right now, we are seeing sort of optimum reduction in LCOE by looking at turbines that could be sort of between 3 and 4 megawatts. As I said, there is a restriction there in terms of swept area, because of course the seabed does represent a constraint. Even with our floating technology, which removes some of the problems of deep water sites, swept area can only obviously fit in whatever water you've got. So I think that gives one aspect of it. But beyond that, there's not really a limit beyond that. I can quite easily see hundreds of megawatts of projects in resourceful areas. Now that could be things like the Bay of Fundy in Canada. There's up to 200 megawatts of consented sites up and around the northeast tip of Scotland. Apparently, I think it's San Bernabeu Strait in the Philippines looks like it could potentially have huge resources in relatively deep water. So I think that there's definitely these can be significant projects of significant scale. I'm maybe less convinced about the coupling with and co-locating with offshore wind projects. you know, ultimately, while tidal can be negatively correlated with wind, i.e. we can be producing energy when wind is not, if we are generating at the same time, that just means you need more infrastructure to be able to take it. So there's not really a sharing of infrastructure unless you've got some pretty sophisticated and big scale storage solutions to try and back that, to try and reduce that infrastructure cost. So, I mean, right now in the near term, I'm very much seeing these as, you know, standalone sites that stand on their own two feet in terms of economics, in terms of commercial viability, and of course, in terms of volumes of production. But moving that back though, you know, Orbital has up to this point very much been focused on this utility scale market. But the solution itself is robust, and we very much see ourselves as potentially having, you know, analogous benefits in run of river. You know, the same conceptual benefits can be deployed at a much smaller scale. And as Elaine said, you know, we've already deployed a 250 kilowatt unit successfully at EMEC, you know, best part of a decade ago. So, you know, we definitely see that as another market opportunity.
Okay, thanks, Chris. Yeah, and I take the point about the co-location of tidal and wind. I think tidal and wave are kind of different beasts with different resources and different business models, so it may make more or less sense for different types of technologies. We've got a question from the audience about the impact. I'm just going to get it up on screen now. What would you for the developers? But in fact, to ask it to Elaine from EMEC, because I think EMEC will have the widest possible institutional experience of this. But Elaine, what's your experience been with the environmental impact, I guess the local environmental impact of wave and tidal deployments?
Well, I guess it depends on what aspect of an environmental impact are you talking about. So is it collision with marine mammals, collision with birds? Is it acoustic noise? So I can say that EMEC's experience and history is that, you know, we've done probably one of the largest bird and mammal surveys of collecting data over the last 10 plus years. And significantly, we haven't seen, you know, any negative impact. Quite the contrary, you know, nature seems to adapt around the devices as they're testing. But when you get to sort of the impacts that talk about fish, pelagic fish or mammals, you know, changing their trajectory, their migratory trajectory, when we get to bigger scale projects, we're going to need more, you know, environmental monitoring in order to collect that data. So, so I think at this time for single deployments that we've seen at EMEC, we have not seen a negative impact. But when we do get to larger scale projects, you know, the importance of environmental monitoring is still going to be there, whether you're in offshore wind or you're even in oil and gas. I mean, they still do a significant amount of environmental monitoring to make sure that there's no negative impact. I hope that answers the question.
Nope, that makes perfect sense. Yeah, no sign of negative impact so far, but it's part and parcel of developing ocean energy, so it's one we'll need to keep on working on. Simon, I'll move across to you. The Tiger project, I saw from your slides, it was kicked off in 2019 and it's still got a year to run. It's not finished yet, but have there any learnings come out of it? Like has anything the supply chain from the Tiger project that's surprised you, or you realized something you didn't know before from the project?
Yeah, thanks, Donna. We've probably got nearly 2 years left to run, actually. But in terms of supply chain, I mean, we've had a great response from the supply chain to date with some fantastic ideas coming forward. And it's interesting to see how the supply chain can almost move seamlessly between sort of wave, tidal, and even floating wind. So from a UK perspective, we've got a very strong, you know, overall marine supply chain here. And there's opportunities to step up and consolidate that and grow that capability, supporting the sort of levelling up agenda that we've got here in the UK. So I think I've been really impressed with the way that our supply chain can turn its hand to things. It's got some great ideas on the shelf. It just needs support to help develop those. And, you know, there's great market opportunity for them as well. particularly looking at sort of things like subsea cables, connectors, subsea hubs, and then into the realms of new materials as well, stronger, lighter new materials, different offshore installation techniques, trying to take, recognizing for particularly for tidal, we've got very short installation windows. We have to get everything right, bang on first time to take advantage of what is often probably only 20 to 30 minutes, 40 minutes of installation time. And boy, these guys on these vessels really know what they're doing to get these things installed, and have really solid sort of mitigation plans. So, really impressed at what the supply chain can achieve. But I think it could go a lot further as well. And I think, with a clear route to market, that'll really turn the volume up then on what we can, and see those sort of knock-on benefits then into coastal communities where a lot of this is going to happen.
Okay, let's stay with that subject of supply chains and maybe offshore operations as well. Ocean with an O, not an M. You mentioned that Minesto's background is actually its automobile. It's precision manufacturing, it's Saab. But in terms of the work that Minesto has done, either in Wales or in the Faroe Islands, have you started to tap into this existing supply chain that's serving other offshore sectors, or have you been able to forge a path on your own? And where do you see Minesto tapping into that supply chain as it expands?
Yes, I think it's a bit of both. I mean, the success has been. I'll give you a case study on Wales actually. So if you look at the sort of companies we managed to engage, there are numerous companies. I think we're 40 local supply chain companies that we've been able to engage with there. But I would say that as this is a developing industry, and the point came up before, there are some parts of the sort of technology, maybe the more specialist parts, such as the wing, the generator, for example, that we would have to sort of draw on a supplier from outside of Wales and maybe outside of the UK to bring that specialism on board. But what we've seen is that there are sort of really high quality supply chain companies out there, quite locally, that we're able to start to see a potential for a diversification from not what their activity is, but from the industry that they've worked in. So doing more of what they are good at in a new industry. That's where we've been able to bring about success in that sort of clustering of a supply chain hub locally. But again, I think for us to be able to really push that supply chain forward and to develop that into something that has huge amounts of local content, there is need to bring that sort of specialism, or the ability to deliver that specialism for the wing, for the turbine, for example, more locally.
So
that answer your question?
Yeah, no, exactly. It's taking what's available now and really customizing it for our technology,
exactly,
which is different and has its own needs. Maybe the same question to Cameron. I mean, your device, I mean, the gas sector, as I understand it, is a potential market and a potential client base. But is it a source of potential suppliers for you as well? Do you see it that way? I think you're on mute there, Cameron. Yeah, you're good.
Yes, absolutely. The oil and gas represents a market as well as a supply chain. Within our Wave Energy Scotland project, I think we were something like 80% Scottish content. A lot of that came through companies that traditionally supply to oil and gas, but a lot of that came through companies that actually, Scotland's had been working on marine energy for the past 20 years, to be honest, and so there's a lot of expertise and built up supply chain that is actually specific to marine energy as well.
Yeah. I suppose we've been doing this so long that we start to have our own kind of skill base as well that can be applied to other sectors too. Maybe a similar question just for Elaine, because I remember during your presentation you made a few points about some of the operators in Orkney cutting their teeth with some developments and also attracting skills to Orkney that are useful for ocean energy. I mean, was there an existing skill base on the islands already prior to the start of an EMEC that could be leveraged from kind of previous offshore work that was happening in the sector? But was there a base of skills already in Orkney? Or was it really building it up from scratch?
Well, I'm just going to use an example of one of the supply chain companies, but they came from fishing. They managed fishing vessels, but they saw the opportunity in renewables and the activity that was going on at the EMEC site, and then they basically pivoted and they developed they acquired new vessels. We've even seen other local supply chain marine contractors who are getting more into product development. So we have a contractor who has developed their own drill pile. They're small companies. They're not the larger oil and gas companies, but they have been agile at being able to pivot and be able to address the needs of the sector. As far as what was here and existing, I'd say it was through the attraction of the Palamises of the world and Open Hydro and Voith Hydro, when they were coming onto the site in the early days of EMEC, that were really attracting all kinds of different marine supply chain companies. But the ones who stood the test of time, when we had a drop in activity on our sites, have been the local companies. So the importance of clustering, which is a term that I know that Simon knows well because of all the clustering activities that they've been doing down south in Wales, as well as the clustering activities that are going on the east side of the UK around floating offshore wind. These are vital activities to bring up and to skill up the contractors that are going to be necessary for these deployments as they move from single prototype to full scale to array scale.
Yeah, I think it's quite apt that you're citing the examples of when we got Alstom and Siemens and GE involved back in the day, that there was this kind of a attraction effect for the supply chain, and linking it to Simon's point, because that's exactly what he was saying, really, wasn't it? Once there's a market established with level, that's going to attract in a lot more supply chain. So it kind of brings the conversation around to a loop. Chris, I'm not going to ask you about the supply chain because I think you gave a wealth of information on your slides, but maybe just a connected question. No, it's not really a collected question at all. Somebody from the audience is asking about of the O2. What's its operational lifespan? And the other question as well is, could you say a little bit more about the maintenance strategy for the moorings, or if that's a bit too specific, just the
Yeah, no, not at all. So we design to DNV standards, including the mooring system, which is very important from an insurance point of view. It's designed to have at least a 20-year operational life. In terms of maintenance, the mooring system shouldn't require any, but it will have regular inspections to make sure it's performing as expected, and I'll come back to that in a second. In terms of overall maintenance, I think one of the key things that I want to get here, and again, it does actually feed into the supply chain side of things. At the end of the day, these are large metal structures out in the middle of the ocean, extracting energy and putting the energy back to shore. Whether that's hydrocarbons or whether that's electrons. These are sort of engineering challenges, maintenance challenges, and health and safety challenges that the oil and gas sector is very, very well equipped to deal with. Now, it's engineering. Things are going to go wrong. We can't expect to only go out once every 5 years, do a quick overhaul, and then go back in again and leave it running for 5 years. That's just not going to happen. It doesn't happen with wind, despite the gigawatts of capacity that we've got installed around the globe. So what we need to do, what Orbital O2 does, is effectively just minimizes the impact of that maintenance. We expect to have 1 or 2 interventions a month. It might just be to change a fuse, might be to do this, do that, change a seal. But what we're doing here is making it as cost efficient and as minimally disruptive in terms of uptime as possible, because that's what's needed to make the project economics work, deliver the low levelized cost of energy, and keep delivering that low carbon, low cost energy. So the maintenance, there are maintenance regimes, but it's very similar to wind. It's similar to onshore wind. whether the technicians go on a boat to get to site or whether they go in a van to get to site. That's the target for us. The maintenance regimes and the cost is actually targeted at onshore wind.
Yeah, so building on that footprint and standing on the shoulders of giants in some respects. Okay, we're running out of time. I see there's one more question. It's about the feasibility of these innovations and these technologies for the SIDS market, so small island developing states. And the audience member is making a very good point, is that they can be really helpful in helping these countries transition towards renewable energy. Given that they're so reliant, up to 90% in some cases, on fossil fuels. Now, just from being in the sector for a while, I can tell you that these technologies certainly are valid for these markets, and they are kind of more expensive at the moment because we're getting down those cost curves. So I don't think it's the immediate focus in terms of market deployments, but maybe Cameron, Ocean, Chris, I don't know if any of you, any kind of thing you want to say in terms of SIDS, how they might fit into your project pipeline for the emerging development.
I think it is important. You know, they are tough locations with a kind of unique supply chain, but you know, fundamentally they need to. A lot of these places are operated with diesel generators, and they need to transition to renewables. Sometimes they don't have the land area for solar panels, and you don't want to put up a wind turbine because of the visual effect for resorts and things like that. So I think marine energy offers a unique value proposition.
I'll just completely agree with that. You know, I think it's again, there's a problem there. I think we can offer the solution. We've not got all of the answers yet. There will be a transitional piece, but yes, I think it's a very attractive market for all ocean energy developers, and you know, one that we can hopefully play a part in helping resolve some of these problems and the high consumption of fossil fuels.
Okay.
And just to come in there, I would also agree, and effectively with it not being a small island developing state, but effectively we are targeting that type of market in the Faroe Islands already. So I'll leave it there.
Yeah, it's actually happening in some senses already. Okay, we need to wrap up. We're running out of time. I want to thank all our panelists for taking their time to come and share their experiences with us. I mean, I kicked off this session by saying that ocean energy is going to surge because we've got a lot of deployment to do between now and 2030. And I think the various interventions today just gave the evidence of that. I mean, we've had various developers who have a very clear idea on what their market is, what their strategies are, and how they're going to tailor their devices to reach those markets. They know exactly what that is of their technologies, and they're coming up with very clear strategies in terms of maintenance, operations. They have a vision for their supply chain, both now and in the future. And they have a strong record of delivery and achievement as well. We've also had ORE, Catapult and EMEC doing cross-cutting work, giving much clearer ideas to what the supply chain is looking like, how we're going to integrate ocean energy into the system, and also its environmental impact, which is going to be really, really important. Momentum, we know we're going to expand. We're going to need a lot of capability, and that was one of the strong calls from several of our panelists today. If you're in the supply chain and you're looking for market opportunities, get in touch. We need your skills. Let's get together. Let's make Europe powered by blue energy. Thanks very much. Bye-bye.